11, section 3, day 1. And this learning target is I can multiply special case binomials. In your notes, you should have taken down that there are two different types of special case binomials. And the first type is the square of a binomial. So I want you to write these two problems down. This is not problem 3, this is problem 2. And write down x plus 2 squared and x minus 1 squared. So what you need to remember about this is that when we're raising something to a power, we're saying everything that's being raised to that power multiplied by however many times this power is put up here. It could be 3. I would multiply that times itself 3 times. But here it's just saying squared, so I'm going to multiply this binomial times itself. Now, one common error I see is that students think that they just need to distribute this exponent to everything inside of the parentheses, because when we were doing our unit on laws of exponents, that's what we would do. But our examples during that unit did not include addition in the middle, which is why I need to write this out as one binomial times another binomial. So we're going to go ahead and do that. X plus 2 times x plus 2, okay? And I'm going to use FOIL, or I'm going to use my distribution arrows to multiply this out. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. And I do have some like terms to combine right in the middle. 2x and 2x is 4x. I'm going to write my final answer over here. X squared plus 4x plus 4. Okay? At some point when we're doing this, you're going to see a pattern. And it's possible that you're going to be able to skip this whole step right in the middle. So what I want you to pay close attention to in these special case binomials is the pattern that you see when you look at the beginning of the problem and the end of the problem. So we're going to look at this one, x minus 1 squared. So remember, it's x minus 1, that binomial, times x minus 1. Okay, I can use FOIL or I can use my distribution arrows. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative x times negative x is positive x. Okay, I'm going to move over here for my final answer. I need to combine these like terms in the middle. Negative x and negative x means I have a total of negative 2x. Okay, and I have x squared and plus 1. Okay? All right. Moving on, I'd like you to try these two on your own and see if you can do it. If you've discovered the pattern, you can skip this whole second step, but we'll talk about the pattern here in a moment if you haven't figured it out. But this is 2x minus 3 squared, so I'm going to write that out. 2x minus 3 times the quantity 2x minus 3. Multiply these first two terms. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. Negative 3 times negative 3 is negative 9. Now when I combine my like terms here in the center, I'm going to have my ending answer of 4x squared minus 12x minus 9. Okay? No more like terms to combine, and notice that so far I've written everything in standard form. Now that's not necessarily how we have to do things when we're looking at special case binomials, because when they're written not in standard form, just the way this multiplies out, like this one will result in, we're going to leave them that way. So unless the directions say write in standard form, don't worry about it. But you always need to combine like terms. So 4x minus 2y, I'm going to write that out as this binomial times itself. Okay, these first terms, 4x times 4x, that's 16x squared, My next term is 4x times negative 2y. Remember, I write this in alphabetical order when I have two variables in the same term. So negative 8xy. This middle term is also negative 8xy. And my last term is negative 2y times negative 2y is going to be positive 4y squared. So I'm going to come over here and write my final answer because I've run out of room. 16x squared minus 16xy plus, I'm just going to run down here, 4y squared. Okay, so here's what I want you to look at in terms of the pattern. And the pattern I want you to see is the beginning number and the last number. So the beginning is always going to be a square of this. The last number is always going to be a square of that. My middle term is something different, okay? What you'll notice is it's the first term times the second term and doubled. That's how I end up with this duplicate middle term here that I then simplify to the combined of that, which is this times this and doubled. You'll notice it here. 2 times negative 3 is negative 6. Doubled would be negative 12, okay? Negative 2 times 4 is negative 8. Doubled is negative 16. And that same thing applies to these two as well. That's our first type of a special case binomial. All right, people, here we are with the second type of special case binomial. It's called the product of a sum and a difference. And the reason why it's called that is when you look at these problems, the first terms are the same, the last term is the same, but the sign in the middle is different. This type of special case binomial produces a very recognizable end result. So let's go ahead and multiply this out and see what we get. So, multiplying my first terms, x times x is x squared. My outside terms, negative 1 times x is negative x. My inside terms, 1 times x is positive x. My last term, 1 times negative 1 is negative 1. When I combine my like terms, which are right here, I end up with them canceling out in the middle. So I'm left with x squared minus 1. Let's see if that pattern will follow with the next problem. So 2x times 2x is 4x squared. 2x times 2 is positive 2x. Negative 2 times 2x is that's positive 4x. Negative 2 times negative 2x is negative 4x. Negative 2 times positive 2 is negative 4. Again, these last terms cancel out, or these middle terms cancel out, and I'm left with 4x squared minus 4. What you'll notice here is that with this type of special case binomial, my answer is always going to be a difference of squares, which was a vocabulary term you should have put down in your notes. Difference of squares. Okay? And the reason why they're called that is look at my first term. That's a perfect square. Look at my last term. That's also a perfect square. And there's subtraction sign in the middle. When you notice that you are working with the product of a sum and a difference that follows this pattern, you can jump straight to the final answer. So what I'd like for you to do is I'd like for you to write down 3 and 4 in your comp book, and I'd like you to try them on your own and see how you do, okay? So this first one I'm going to go ahead and show the whole process. 3y times 3y is 9y squared. 3y times negative 2 is negative 6y. 2 times 3y is positive 6y. 2 times negative 2 is negative 4. These cancel out, and I'm left with 9y squared minus 4. Okay? I'm going to go ahead and jump down here, and I'm just going to jump to my final answer. 4x times 4x is 16x squared. My ending term is going to be 25, and it's a difference of those. Okay? All right, so in today's assignment, you are welcome to skip this middle term if you feel like, or this middle step, if you feel like you can go right to your final answer. Of course, if you have any questions at all, please reach out. I'm here to help. Thanks.